Hi, and welcome to a video where we're going to talk about this um, sampling methods Desmos activity that I assigned out to you. It doesn't count against your grade, but thank you to those who did it. And if you didn't do it, I would love you to watch this video even still, because you can learn a lot from those students that did do it. So what this activity did was it took an American city, specifically it took San Antonio, and we looked at the different how it was economically segregated within the city. And most American cities have severe economic segregation. So that means that households in the same community have similar incomes, but then incomes across neighborhoods tend to be quite different. And this can affect things like, how are we going to fund the schools? Are we going to do it by property taxes based on the value of these homes for the schools that are in that community? Or are we going to do it a different way? And so you can see why this would have implications into the real world. So what you guys did was look at this map, and we did different sampling methods to decide what was a representative sample of the whole population of San Antonio. So our first one, I'm going to go to the results now that I have put together. The first one was the judgment sample. So each student looked at this map, and for the judgment sample, they just picked 5 numbers that they thought were representative just by looking at it. So they picked the home number, and they tallied down the income for those home numbers. The bigger the circle, the bigger the income, smaller the circle, the smaller the income, and then the different colors represent different races. And then what Desmos did was it calculated the mean, which is the average for the 5 homes that you chose. And then what I did was I took the data that each student did. So each student's average shows up as a dot right here. So one student, based on the 5 homes they chose, their average was around 30,000 in income. And then another student, for the average of 5 homes they chose, it was up here around 140,000. So we put these all together, you can see in this dot plot how spread apart this is based on the 5 homes that particular person chose. You can see this class, we have it pretty spread here. And that's because it's a judgment sample, which means it's actually biased, because there's no method to the randomness. It was just what we thought was a good representation. There wasn't a method to it. And so because this is a biased sample, it really doesn't matter how spread apart this is, because the estimates are trash anyway. As harsh as that sounds, there's a phrase in statistics where if you put garbage in, you're going to get garbage out. So if there's no method to the randomness that you're choosing, if you just think, oh, I'm choosing random ones that look good, that is a biased sample, and it doesn't really count towards anything useful. So let's go to the next one, where we actually did a simple random sample. This one, students used a random number generator, and the random number generator actually generated numbers, and those were the houses that they chose for their 5 houses. And then Desmos computed the average income for those houses. You can see how less spread apart this is than the one above it, right? The lowest wasn't as low as the red one, and the highest wasn't as high as the red one. So it was more clustered around. Actually, I forgot to mention this black line. This black line is the true average, for the income of all the households in San Antonio. So we're trying to get as close to here as possible with our samples. And you can see this one is a little more clustered around the mean, which we like to see. We don't want it to be too spread apart. The more spread apart we are, the less precise we are. So if we have moderate variability, that means we are moderately precise. And this one we can consider unbiased because it is a random sample. So that one got even better. Let's look at the different method where we did a cluster sample next. A cluster sample is where we break it into groups, and we take all the observational units from some of the subgroups. So this one, the random number generator generated one number, and then the students chose all the houses around that one number. So they just chose all of the ones around that one subgroup. And so we just took all of the ones from one subgroup. And sometimes cluster sampling can have more than one subgroup that we choose from, but this one we just did one subgroup. You can see it's unbiased because it is random. We did a random number generator to choose the one house that we were going to start with, and then the 4 around it, making 5 total. But it does have high variability, which means it is pretty spread apart. Like, again, like the original one, remember the red one, how it's spread apart it is? This one, again, is pretty spread apart. You can see it's as low as like 25,000 and as high as 150,000. So it's not really clustered around that true average right there. It is the easiest to implement because you only have to drive to that one neighborhood if you're going to take polls from those people. But But yeah, it is highly variable, which means it's not as precise. The next one we did was stratified. And stratified is where you take some observational units from all the subgroups. So this is the one where we broke it down by race. In fact, I'll just go real quick to that slide. Oops, right here. You can see we broke the circles down by race, and then we did a random number generator for each of the subgroups. So we took sum from all. For stratified, we take sum from all. And in this case, we just took 1 from all the subgroups. And you can see actually this one was unbiased because it was random, but also had really low variability. It was not as spread apart. We could see that a lot of people got their average to match closer to this true average than, maybe the one above it. This is the hardest to implement because you need a lot of info to properly stratify. So we would need to know everybody's races, and it also would have to drive across town to every single neighborhood, every single house that you chose that within those different stratas, which are those different race groups. So so it might be the hardest to implement. And then we did systematic. Systematic was where we just chose one random number, and then we did every 20 after that. And this one actually was unbiased because it was random, and it was moderately had moderate variability. It wasn't as spread apart. So that one was also a good one. So I hope that was helpful for you to see the averages of all your classmates, so you can see how this looks and the differences between the different ways we can sample things. Just going on to mention a few more things before I'm done. We obviously want to be highly accurate and have high precision, which means low variability, so not as spread apart in our data, and to have it be unbiased. That's kind of the hit the target right on the mark. We do not want low precision, low accuracy. And then, there's trade-offs with high precision, low accuracy, or low precision, high accuracy. These notes here just kind of go through all the things we just talked about there above. So I just wanted to mention one last thing, property taxes. Like, so what does this all matter? Well, suppose you were the mayor of San Antonio, and based on the activity in your analysis above, you're supposed to figure out how you're going to fund schools. Do you want to fund schools based only on property taxes from the homes around the school? Do you want to fund all the schools equally? Now, here's an example of a high income property. So they're going to generate a lot more money for the school than a low income property if it's based off property taxes. So you have to decide, and because you can't survey every single house, you might want to take a sample of houses and see how they feel about the issue, and how they would want. So you want to get a sample that represents all of San Antonio and not just one part, not just the low, not just the high. So this gives you something to think about on why it's important to consider how you're going to sample and which ones would benefit you in your sample. It also gives you something to think about with when you read studies out there in the news. When they say they got a sample, you want to think about, how did they do that sample? Did they do that sample in a way that was giving something true to the true average, somewhere close, or was it something that could have been way far away from the true average? So it's always good to think about those things, and I hope this activity and wrap up was helpful to you.